Hello again. In the previous release of the SharkC64 compiler, I did some refactoring. So what was that all about? Let's have a look. As you might have guessed, I'm using an Agile approach for the development of the SharkC64 compiler. So instead of a fixed plan, I implement one feature at a time and adjust the plan after each increment. Although this sounds like a good approach, it leads to spaghetti code over time. So every now and then, some part of the implementation has to be redesigned and refactored. This time I refactored the parsing of expressions. As I explained in an earlier video, the purpose of the parser is to take a sequence of tokens and construct a syntax tree from them. The implementation of the parser consists of several interacting classes. The reader provides an access to the sequence of tokens and it is used by all the other classes. Parser calls a module parser that uses the other classes to parse various sections of the module. A body parser in turn calls an assignment parser to parse assignment statements. The assignment parser then calls an expression parser to parse the expressions in assignments. The expression parser is also used by a constant parser as well as a variable parser. So what was refactored and why? The reason for refactoring was actually in the implementation of the expression parser. In the heart of the implementation, there was a recursive function called parseExpression. It did all the heavy lifting. Although it was thoroughly tested, it lacked readability. The use of recursion made it difficult to follow the execution and to debug it. Also, the use of an operator map made the precedence order implicit. This meant that it was difficult to see just by looking at the function what was the outcome. It just really wasn't obvious how or why it worked. Also, the use of recursion made it hard to estimate why some later change would not work. This in turn made the function highly inflexible, whereby it limited the form of expressions also in the future. So, because of these reasons, this function had to be refactored. By the way, this is what the source code looks like when you are using Kotlin as the programming language. So, here's the refactored function. The resulting code is much cleaner. It is also very clear in which order the operators are processed. This makes it easy to analyze the code if it needs to be changed. There is now more confidence to the actual implementation, as reasoning of its execution is now much simpler. Of course, this implementation may change later on depending on the future requirements. The refactoring of the parseExpression function meant also adding of new classes. In fact, the expression parser class was split into 8 classes. In addition to these classes, there are also some supporting classes which are not shown here. Although the number of classes increased significantly, it is not a bad thing. In fact, it makes implementation more manageable because each feature is in its own class. Before, the features were intertwined in the implementation in one class. So, how was the source code refactored without breaking existing features? Well, this is actually tackled with the unit tests. There are currently more than 250 unit tests for the features of the SharkC64 compiler. The unit tests cover almost all the classes. If we look at the parser before the refactoring, each class was covered by unit tests. When the expression parser was refactored, most of the unit tests remained the way they were. In this way, the unit tests made sure that the new implementation did produce exactly the same results as the previous implementation. Moreover, with the addition of new classes, a bunch of new unit tests could be added. These unit tests made no sense before because of the use of recursion. The unit tests are really instrumental for the development of the SharkC64 compiler. Without them, the refactoring would be impossible. So, I'll keep on working with the compiler. Thanks for stopping by and see you soon!